So when we left ourselves at section 1.2, we had talked about interval notation. So just real quick warm-up problem, just to get us all loose and ready and excited to be doing some math. Today, I'm just going to write up a set on the board, and I would like you just to real quick write it in interval notation. We're going to be using interval notation a lot today, and we're going to use it pretty much every day for the rest of the class. So it's good to have an understanding of this. So write this set. Well, I'm going to give you two, just because let's warm up properly. So here's two sets. The set of numbers such that x is greater than or equal to 5 and less than 19. And then the set of numbers such that x is, let's say, greater than or equal to 14. Okay, so those are the two sets. Please write those two sets in interval notation. Those are not on the note sheet. Those are just, so you can flip to the back if you need a place to write or something. These are just extra warm-up problems. So, all right, so here we go. This first set, remember, interval notation, lower bound, upper bound, and then on each side we either put a parenthesis or a bracket, depending on what the information tells us. What's the lower bound of this interval right here? Great. What's the upper bound of that interval right there? Great. What am I going to put at the 5 end of this interval? A bracket, because there's an equal. What am I going to put at the 19 end? Parenthesis, because there's no equal. Great, there's your interval. That communicates the same information as that. Okay, this one right here. What's the lower end of this interval right here? 14. What's the upper end of this interval? Infinity, because this says all of my values are bigger than 14. There's no end game given to us. So we use this. Remember, infinity is a direction, not a destination. That's going to affect what we put at the infinity end. So 14, what am I going to put here? A bracket. Bracket, I think. Why am I going to put a bracket there? Equality. What am I going to put at the infinity end? Why am I putting a parenthesis there? Exactly. That's what the perkster told you on Monday. Always put a parenthesis at infinity because you can never get there. Great. Okay, so we're going to continue our section 1.2. Now we're getting kind of to the really important part of 1.2, the idea of what a function is, which is what we are going to be talking about all semester, functions and things we can do with them and relationships between things. So here we go. So where we left off on the front page, the definition, a relation. Okay, so a relation, which is short for relationship, okay? A relation is simply a set of ordered pairs. And in parentheses, I'm just going to put it denotes a relationship. Right below what you're writing, you see that I have given us 3 sets of ordered pairs. And in fact, on the second page, there's a whole bunch of other sets of ordered pairs that we're going to have. We're going to talk about just different looks to these and then different aspects of this. So we've got those 3 sets of ordered pairs. In and of themselves, they're not very much fun. We're going to flip the page, but be ready to flip back. We're going to do something with those examples. But the reason I defined relation for you is because you need to understand what a relation is. It's just any set of ordered pairs. A function is a relation. So it's a specific type of set of ordered pairs. Okay, function is a relation. It's a set of ordered pairs in which each x value corresponds to a single y value. I'll give you a second to write that down. Super important. And we're going to practice that definition. That's kind of one of our big tasks for the next 15 minutes or so as we go through the rest of section 1.2. Another way to think about a function, and I've teed it off there, and then the next slide says a visual explanation. A function is a relation in which each x is listed once. Okay, so if you want a really quick, just kind of visual way to skim through, okay, what this definition, this is the fun math definition, but the way we can summarize it is a function is a relation in which each x is listed once. That will help us get used to identifying things as functions or not, as we get used to the mathematical definition. Once you've done that, once you've written that down, if you would flip back to page 1. All right, you already have this on your page. This is example 4, yes. All right, this is my last one. There we go. The first question we're going to ask is this a function or is this not a function? It's why is it? Why you say yes? There's no, the x is each x is listed once. What that means is each x corresponds to its own y value, a single y value. In this case, -2 corresponds to 3, 0 with 6, 3 with 5, 7 with -2. Each x value only has one y value, not multiple. So this is a function. Great job. So if you would, I'm going to write the next 2 examples on the board, but if you would, please identify B and C under exercise 5 as function or not a function. All right, so B, set B, is that a function or not a function? Why are you telling me it's not a function? The x value 1 repeats. Okay, so that means the x value 1 corresponds to the value 2, but it also corresponds to the value -4. Okay, so this x value corresponds to more than one y value. That violates the definition of the function, so this is not a function. Okay, excellent. Set C, is it a function? Yes or no? Okay, now this sometimes we have controversy. Okay, and there's a reason I picked this one. Is each x listed once? Yes. Now, sometimes people get a little confused and say, but hang on, Berkster, the same y value happens. The definition of the function had nothing to say about the y value. It doesn't matter that each x corresponds to the same y value. All that matters is each x only has one y value. So this is a function. There will be a situation, we're going to get about halfway through the class, and we're going to talk about specific types of functions that are really useful. And there is the situation where each x corresponds to a unique y value. It gets its own. That's called a one-to-one function. You do not need to know that right now. That excitement is later in your life. Okay, so be prepared. All right, again, flip to the second page. We'll come back to the first page. A couple other bits of terminology that we're going to get used to, and that's what we're going to spend most of the rest of our time today getting in this section, getting used to. The domain. Now, I'm guessing a lot of you have seen this before. Does anyone remember what the word domain is referring to? The x values. Okay, so the domain is the set of x values. Likewise, the range. What's the word range refer to? The set of y values. Yeah, perfect. Just getting used to speaking the lingo here. So one more time, sorry to have you keep flipping. I don't want anybody to get paper cuts or anything like that. One more time, we're back to the front page. Example 4, set A. Well, help me out. The domain, I'm just going to call it D because I'm really creative. D is going to be the set that contains what values? The x. So that is -2, comma, 0, comma, 3, comma, 7. Hey, Mr. Perkins, do I have to list them in number order? Technically, you don't. Okay, on the test, I won't mark it wrong if you put them out of order, but it will help you when you're doing problems. It is easier to see things when they are in number order. So I would say make an effort to do that. It's for you more than it's for me. How about this one? How about the range? What's the range of this going to be? Yeah, and so I'm just going to flip them around. So -6, -2, 3, and 5. Fantastic. Great job. So if you would do this for me, let's do the domain and the range for both B and C. Just since I'm assuming, even though some of you have seen this before, I'm not assuming everybody has. All right, so I'm just going to go ahead and write these down. If you have any conflict or anything you need clarification on, please let me know. I'm happy to help. That's why I'm here. Otherwise, why do I need to be here? So the domain of this is going to look like -5, -3, 1. You only need to write the 1 once. Okay, you don't need to repeat that. And then 0. There's my domain. The range is going to be, if I'm going to do it in number order, is -4, 0, 2, 6, and 7. Questions, comments, concerns? All right, for C, the domain is 2, 3, and 7. And then the range is just 4. It only has one element. So sets of ordered pairs like this, written like this, is the first way that you'll see relations. Now on page 2, if you go down to example 5 and exercise 6, tables are another way that you'll see relations or relationships presented to you between your x and your y. If you would, for both of those, for each of them, tell me if it's a function or not a function. And then for exercise 6, do the domain and the range. You don't have to do domain and range for both of them. But for both of them, function or not a function. All right, example 5, the first one on the left. Is this a function or is it not a function? Each x happens one time. Remember, it doesn't matter about the y's. Each x happens once. This indeed is a function. Great job. How about this next problem? Function or not a function? Why is it not a function? The -3 repeats. Okay, again, just because I'm reiterating, because I'm hoping it'll sink in, because I understand when you first encounter this definition, it's a little funky. Okay, this means that this x value corresponds to more than one y value. That violates the definition of the function. Definition of the function is each x corresponds to only one y value. Okay, so it only has to fail the test once, and this one does. But I did ask you to write the domain and the range. You can do that whether it's a function or not. So hopefully what you wrote down for the domain was -3, 4, and 7, or some order of those three numbers. And then the range is equal to -9, -1, 3, 6, and 10. Perfect. Sets of order pairs, tables. The last pair of examples on that page are mappings. Okay, a mapping takes you from one side to the other. The arrows indicate the relationship. So give it your best shot. You may not have seen a mapping before or not, but go ahead and write down function or not a function for each of those. And then please do the domain and the range for the one on the left, example 6. One on the left, which I've labeled example 6. Is this a function or not a function? It's a function. Each x has one arrow leaving it, meaning it corresponds to one y value. 2 with -4, 7 with 5, 13 with 0. So it is indeed a function. The domain, because I asked you to do that for this one, hopefully not too big of a deal. And then the range is -4, 0, and 5. How about this problem right here? Function or not a function? Why not? You're totally right. Not the 0. Okay, it is not a function. You are correct. But remember, it has nothing to do with the y values. Okay, it has everything to do with the x values. Which x value violates the definition of function? The -2 down here. It has 2 arrows leaving it, meaning this x value corresponds to 1. This x value corresponds to 2 y values. Okay, there's 2 y values there. So this is not a function because of the -2. Okay, so when you're looking for function or not a function, we're going to keep doing this. I've got some more examples. We are looking at the x values to make that determination. The y values do not tell me whether it's a function or not a function. Okay, so that is the answer to the question. Flip to the next page, please. So example 7, I gave you a nice blank graph, so there's nothing really to talk about just yet. So this is example 7. They told me by the end of today, they will allow me to project the screen up there to record it. So hopefully that's going to be true. That way you don't have to look at my drawing ability, which I lack. Okay, so I'm just going to put some points up here and I'll label them so that you can put them on your page so that we're looking at the same thing. So here we go. I'm going to go, let's say, to -3 and -2. Then I'm going to go -2 and 3, 0 and 1, and then one more point, 4 and -1. I just don't want to clutter this up too much, but I do want to make my point. And while you're writing those, Okay, and you can fill in the second graph as well. I've labeled all the points. This one only has 4 points. This one has 6 points. There's nothing special about the number of points, just that I lose interest really quick. Okay, so ADHD or something, I don't know, not official. Too much caffeine. So the first question I want to answer about each of these is function or not a function, and then I'll mention domain and range, but I'm pretty sure you could all list the domain and the range for me. But the big thing here is we're going to turn our attention to graphs, because that's what we're going to spend a lot of our semester doing, is graphs and looking at graphs and those sorts of relationships. So is there a quick and clean and easy way that I can look at a graph and decide if it's a function or not? And we're going to use these two here to help me make that distinction. Okay, so this first one, example 7, if I asked you if this was a quick quiz and your whole grade determined it, what do you think? Function or not a function on this? Yeah, each x, right? Each x happens once. Okay, so this one right here is a function. Example 8. Function or not a function on this one? Not a function. In fact, it fails twice, right? -3 has 2 y values, right? And then 2 has 2 y values, so it's not a function. Well, here's what we noticed then. Okay, and this is going to be our test to determine if a graph is a function or not a function, meaning does it line up with that definition of a function, which says each x value corresponds to a single y value. I'm going to take this ruler, I'm going to make a vertical line out of it. Vertical means straight up and down. This vertical line is going to represent x values. As I slide this ruler across the graph, representing each different x value, how many times does the ruler hit the graph right here? How many times does the ruler hit the graph here? And thank you for repeating for me. The vertical line representing the x value hits the graph once, meaning there's only ever one y value, right? This is called the vertical line test. The vertical line test means if I take a vertical line and pass it across a graph, if it hits the graph one time everywhere, it's a function. Let's do this one right here. At -4, the x value -4, how many times does my vertical line hit the graph? At -3. There's the problem. Okay, let me just draw this vertical line so that I don't have to hold it up here. I'll do it over here too as well. So notice this vertical red line, which represents the x value -3, hits the graph in more than one place. That means there's more than one y value. This vertical line that represents the x value 2 hits the graph in more than one place. So that means there's more than one y value. That's why not a function. Okay, that's how this picture relates to that definition. We doing okay? This is big stuff. I mean, this is good learning. You're going to use this all semester. Okay, so now example 8. I want to make a distinction. I'm going to leave that graph up here for just a moment, but I do need a little room. Example 8 is a circle. We will learn more about circles, the equation to make a circle, some fun things about them later in the class. But the first thing I want to ask you, if you notice, almost so close to being a very good circle. Not that one. Okay. Notice how many points are on this graph? 6. So let me do this. I'm not going to do both the domain and the range, but just so that we're making a distinction, I'm just going to list the domain here. Okay, so the domain of this graph. Well, my domain, my x values, I've got the x value -4. Is there a point at -5 here? I've got a point at -3. Is there a point at -2 or -1 or any of the points in between? No, there's a 0. There is a 2. Those are the only distinct x values used. There were 6 points, which translated into 4 x values. Are you tracking with me so far? Okay, because I don't want you to make this. This is one of the most common mistakes on the test that I want you to avoid. How many points are on this graph? A lot, yes, accurate. An infinite number of points, in fact. So I can't, when I ask you the domain and the range in a minute, I can't just say, let me pick a few points like -5 and 0 and 5 and write those down. Okay, this is where interval notation. That's why I spent the last 15 minutes of class last time going over interval notation. And it's going to affect your life a lot. So again, practice it. Make sure you can do it quickly. So first thing I'm going to ask you about this graph right here is it a function or not a function? Not a function. Vertical line test, right? Only has to fail at once. So let's just put the vertical line here and notice, whee, at whatever x value that is, there's 2 y values. That's why this is not a function. Now we're going to do the domain and the range. And since there's an infinite number of points, we're going to describe this as an interval. So domain, we're looking left and right. Okay, we're only looking left and right. What's the furthest left this graph goes? Oh, said with authority, I love it. What's the furthest right this graph goes? Okay, there's my upper bound, my lower bound. Now, does it go through -5 and +5? Are those points on the graph? So what am I going to put on each end here? Great job. Excellent. And because it's a circle and it's centered at the origin, the range is not very interesting, but we're going to get ourselves used to looking up and down now for the range, the y values. What's the furthest down this goes? -5. What's the furthest up? And again, it goes through those points, or at least it should. It does on your paper. My drawing, not so much. So I'm going to put brackets there. So please, while I draw exercise 9 on the board, if you would do the same things. Function or not a function, domain and range, please. Once again, function or not a function? Not a function. The vertical line test, pick a place. The vertical line test, it's going to fail. It's going to go through the graph in more than one place. So it's not a function. The domain, how far left does this graph go? -5, how far right does this graph go? Yeah, no tricks or gimmicks. I'm not trying to trick you. So just go with how it looks. Okay, I'm not gonna, on a problem like this, I'm not gonna throw in decimals and have you approximate or anything. That would be mean and rude. Try not to do that to you. How far down does this graph go? -2, how far up? Great job, excellent. I've got one more that I'm going to do, then I've got a few more that you are going to do, and then we've got one more quick little topic from this section, and then we're going to jump into section 1.5 and get started with that. Oops. Okay, so this next thing is called a parabola. You're going to become very good friends with the parabola in chapter 2, no, not chapter 2, the next unit. So whatever chapter that is. So here we go. We've got 1, 2, 3, and then over looks like 1, and we'll do this. There we go. All right. Here's my vertical line. Function or not a function? Every time I put a vertical line there, it's only hitting the graph one time every time. Okay, so this is a function. Each x value has only one y value that goes with it. Okay. Domain and range. The domain, left and right. Yes, these arrows tell you it just keeps going in that same direction. It's just going to keep going outward forever and ever. Okay, so it's not going to stop. It's not going to suddenly double back. Okay, otherwise those arrows would be meaningless. So the furthest left this goes is negative infinity, forever to the left. The furthest right this goes is infinity. Remember, we talked about last time that this is the way you write all real numbers. Okay, so that means every x value is used for this function. What do I put at both sides of this? Oh, yes, said with boldness. I love it. Okay, the range. How far down does this graph go? -3. How far up is this graph going to go? It's going to go forever up, so infinity. I'm going to put a parenthesis there. I'm going to assume you're going to yell a parenthesis at me. At the -3 part, what am I going to do? Put? Yep, because it goes through that point. So we'll put a bracket. Great job. You're doing excellent work. Love it. Do the next one, exercise 10 on that page, please. All right, so is this a function or not a function? Again, for the same reason as the circle and the ellipse that we saw earlier, if I do a vertical line, it hits the graph in more than one place, so it's not a function. Great. So then the other thing that I want to know is domain and range of this. So the domain, left and right, how far left does this go? What's the lowest? -infinity. What's the furthest right this goes? 5. Excellent work. I'm going to put a parenthesis here, bracket here. How about up and down the range? How far down is this going to go? Keep going down, 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 go down, forever, ever, ever. And then how far up? You're exactly right. Great job. Okay. All right, so domain and range functions, practice that. Okay, very important skill for this class. We're on the last page of this. We're going to do a few of these problems. Finding function values, being able to work with functions. So my example 10, says for the function in example 4, which I've written here, you can look up here or you can turn your page back to example 4. It's on the front page. We're going to find the following function values. This is function notation. I am 92% certain everyone in here at some point in intermediate algebra saw function notation, but this says, okay, if this is my function, okay, if this is my function f, then what's the value of f at 3? What's the value of f at 7? What's the value of f at 11? Here's the only thing I'm going to mention about function notation at this point. In the parentheses, that is what value? The x value, that's the input. Okay, so we want to know what corresponds, what's the output. So according to this function, what value corresponds to the x value 3? Right here, 5. 3 goes with 5. Perfect. There's going to be problems like this on the test. 3 points. Okay, so hopefully. What value corresponds with 7? Right here, 7, -2. What value corresponds with 11? There isn't one. So what we'll say for that is that this function does not define such a relationship. So we'll just call it undefined. So we're going to go through a couple of these problems. If you would do the same thing for example, for exercise 11, example 5, which is on page 2, not exercise 5, but example 5, the table. You would answer those questions about the table, please. The table's on page 2. So what did you say is the function value at -6? 2, right here. -6 corresponds to 2. Great. What did you say is the function value at 11? 2 as well. That's fine. Remember, the y values don't matter. It is a function. We're going to skip down to exercise 13 on that page. It says for the function in example 9, it's the graph of the parabola that we were looking at. Figure out what the function value at -2 is, please. So when you look at the graph, again, you told me earlier that -2 represents the x value. So what's the y value of the point at the x value -2? 1, 2, here I am. What's that y value right there? It is 0. Being able to read graphs is going to be an important skill. All right, we're each going to finish with one of these last 2 problems. I'm going to do one of the ones in example 11. Again, just recalling, refreshing our memory about function notation in arithmetic. So in example 11, I've got f of x. So now instead of having a table, instead of having a set of ordered pairs or a mapping or a graph, I'm giving you the equation that represents the relationship. So the function is defined by 5 minus 2x. Okay, this tells you whatever x value you put in, this is the y value you're going to get out. That's the relationship. So I'm going to do the function value at -5. Or actually, why don't you do it? Just see how much. If you've never seen this before, then we'll figure it out together. But I'm guessing this is part of intermediate algebra. Should be something you've seen, I'm hoping. What I like to do when I perform one of these, because I am susceptible to make silly, goofy mistakes, which I know some of all of us are. The first thing I like to do is I like to rewrite the function, and instead of the variable, I like to put some parentheses just to indicate that's where I'm going to put the value I'm plugging in. Okay, so if you struggle with these, that's a good first step. And now I'm going to take the -5 and I'm going to put it in where the x is. This also helps me with signs, so I don't goof up my signs. So order of operations says I do my multiplication first. So -5 times -2, what's that going to be? So I have 5 plus 10, and then 5 plus 10 gives me 15. So that says that when I plug in x is -5, I get the y value 15 out. All right, so as our last problem here on the right, do I don't even know where I put my sheet. For some reason, I packed it in already. Do the second problem right next door in exercise 14, g of -3. G of -3, I've written down my function. Instead of x's, I put parentheses. I picked the -1 here on purpose because sometimes we get a little sloppy with our negatives and when we're squaring. So I want to make sure that we've got that down straight. So I'm going to put my -3 in here, -3 here. Order of operations says you always do your exponents first. Okay, so got my exponents. What's -3 squared? What should I have right here? 9. Okay, so +9 is what you should have right here. So I'm taking one step at a time. I know you can trim some of this and go a little quicker. I get it. That should be a +9. So now the first term, 3 times -3 is -9. -2 times 9 is -18. And so my function value at -3 is -27. And that is the end of section 1.2. Congratulations, you made it.